Hello, and thank you for joining us, and welcome to the OxTS webinar on NAVconfig, which will be run by Lily Munn, one of our support engineers. There will be time for questions at the end, but please feel free to type them into the question box as we go, and we'll get through as many of them as we can after the presentation is over. Over to you, Lily.
Thank you, Caroline. Yeah, just to reiterate what Caroline said, so this webinar will be recorded and it'll be sent out to you all at the end of the webinar. The presentation will last around 30 minutes and then we'll have time for the questions at the end. And you can ask them throughout just using the question tab on the webinar software. Thank you. So our NAVconfig software is to help configure the units. So with this software, you can make configurations from scratch. You can edit ones that you have saved or ones that are saved in the RD files that are logged onto the units. And you can also improve the configuration after a warm-up to tighten the tolerances and just improve the system. With this software, you can also upload feature codes and view the feature codes that are on the unit, as well as the hardware config settings and the firmware that's on the unit. So when you first open NAVconfig, this is the page you see, and you have those three options. So new configuration, modify configuration, or improve configuration. And then when you choose one of the options, you get onto this page. So this is the one for read configuration. The others are slightly different, but you just have the option of choosing where you get the data from, and then also what vehicle the device is being installed in. This option just changes some of the additional configuration options that are later on in the software. So if you choose marine, for example, you get the option to output an additional heave measurement, which is only used in marine circumstances. So the next page is the hardware setup, and this is where you'll input all the measurements that you have taken from the actual vehicle setup that you're using. So the IMU orientation, the antenna placement, and then also just the GPS correction that you're using. You can set that up there, as well as also if you're using a LiDAR scanner, you can set up the measurements and signals that need to be sent between the two systems, just on this hardware setup tab. The next one is for setting up the different interfaces that our system can output over. So the standard one is just the ETH, outputting NCOM over the Ethernet. You can change the data rate as well as send out the triggers if you need them. Here's also the page where you can output the signal if you're using an ABD driving robot. You just tick this box and input the IP address as needed. And there's also the options of configuring all the other outputs, so Wi-Fi, CAN, serial, analog. We also have standard PPS and triggers. The next page is the environment. This goes through the environment that you'll be using the system in. So if you require dynamic or static initialization, what kind of GNSS environment you're in. So it'd be open skies if you're on a test track, but if you're driving around in the city and there's a lot of trees or buildings, you may want to use frequent instructions. And this just allows the system to understand the data that's getting in a bit more clearly and just provide better outputs, as it knows what to expect when it gets, say, more multipath issues. If you are in a city environment, it just knows how to handle them better. Same with the vibration level. If you are in just a standard car, then the vibration level normal, that's fine. But if you're on a motorbike or anything else that has that kind of level of vibration, setting a higher level here is just going to mean the output that you get is a lot better, because the system knows to expect a certain level of vibration. And there's also here the options to just change the heading lock settings, and you can also enable local coordinates through this page, but you can also do that as normal in nav display. So this settings here, just advanced tools. This goes through all the other settings that you can configure on the unit. So these are the slightly more advanced ones. If you are wanting to do more specific things, so you can change the GNSS control. So this changes from the default, which is just using the GPS receiver cards output, to you have the option of changing it to our OxTS GXIX type coupled option. And we also offer a mixed mode, which runs both of those options, the GPS card algorithms and our GXIX ones in parallel, and then we'll output the one that's giving you the best result, and this gives the best RTK coverage. Some of the other options you have are, this is where you configure displaced output, or if you are using a wheel speed input, you can also configure that on this last page. There's another thing that is quite important, which is just the accuracy. These should be set to the default 10 centimeters, 5 degrees for most setups that you are using. And just if you're using the get improved settings, that's when they'll change. So it's always good just to check those before you committed your unit configuration to the unit, just to check that they are what they should be. And then just this last page is just writing the configuration to the unit. So you can just select the device that you want and then just commit it. You also have the option of saving the configurations throughout, just using the floppy disk symbol at the top here. And yeah. So now moving on to the actual kind of use case of NAVconfig. So first what you want to do is install the RT. So you mount the RT in the car, so you're using an RT strap, for example, or if you have your own mounting system. But then you move on to the antennas on the roof. So these, if you're using the standard G5 antennas or tungsten antennas, they'll need to be 20 centimeters from the edge of the roof, or any other interference that you might have, and within the same orientation. So if you look at this top diagram, that just means the antenna cable comes out in the same direction, and then they're in the same plane. This just helps the antennas identify the satellites in the same sky that they're seeing, so you'll get a better dual antenna. And then just having it 20 centimeters away from the edge of the roof just means you have a good ground plane around the antenna, and that just stops the multipath signals that get bounced from the ground up into the antenna from affecting the results. Next is just to plug in the user cable and connect all the other cables, and then you can configure it in NavSuite. You should ensure that your PC's IP address settings are correct. So to communicate with our devices to view the data or commit config, you'll need a static IP address in the same IP range as the unit. Try and use the software. So these are all this is the data that you need to take when you are configuring the unit. So this is just from the RT to the antenna, as well as from the antenna RT to the wheelbase of the vehicle if you are using the lateral slip, as well as taking note of what orientation the car is in, the RT is in the car. So this can be seen. There are small graphics on the RT itself pointing which way the different axes are, and then you can just input that into NavConfig. So these are the measurements that I'm going to use just for this example that I'm going to go into. Now I'm just going to open NavConfig. Let's go back here, and we'll start a new configuration with no device connected, and I'll just select the product that I'm using. So today it'll just be an RT3000 V3. It's going to be in car, so it'll be on land. So the IMU orientation for the example that I've just shown you had the y-axis pointing right and the z pointing backwards. So as you can see, this changes the diagram here on the right, and that matches what was displayed in the car. So you can, just as a quick sense check that this drawing here matches what you're seeing in the car. And if you are using not orthogonal angles in the car, you can specify the exact angle again here, and that will change the diagram as well. So you can view this live. I'm just going to change that back. So if you are using a slightly harder setup, you can just measure it that way. And this, when you input these angles in, they do only need to be to around 5 degrees. And if you do use the lateral and vertical no slip options, the RT can actually work out its forward direction in the vehicle and apply, and you can apply an offset to get those the heading of the RT to match the heading of the vehicle correctly. But I'll go over that in a little bit more detail when we get to those settings. The next is the primary antenna placement. So this is just the 3 distances away. So in our example, the antenna was 1.2 meters ahead from the RT. It was in the center of the vehicle, so it was left by 0 meters. And it was above by 65 centimeters, so 0.65 meters. And then moving on, so the secondary antenna, if you are using one, you just need to measure the baseline between the 2 antennas, and then in which direction it is. So in our case, the secondary antenna was ahead by 2 meters. And you can again specify the exact angle if you are using a non-orthogonal angle. So if you do have a smaller vehicle, smaller roof, you can put the antennas diagonally across from each other to improve the baseline length you have. And then you can just input the orientation angle, this specify exact angle option here. So next is the lateral no slip option. So what this constraint does is tells the RT that this is a vehicle, it's a non-steered axle, and from this the RT can work out its forward direction in the car, and it also adds some constraints to the RT when you do lose GPS signal. So because the RT now knows that it's mounted in the car with a non-steered axle, it knows that it can't just move sideways without any forward velocity, because cars don't just slip side to side. This just adds a bit more constraint, and it means you'll have reduced drift in these GPS banks. So for our example here, the rear axle is non-steered, and that was behind by 0.8 meters. And again, the RT was mounted in the center of the car, so it is left by 0. Also, the diagram again moves the RT to where you are inputting it with the directions, so you can see at a glance if you're putting it in the right place. And you'll have to give just the direct how far below the ground is from the device, and in this case it is again 0.8 meters. And you also have the additional option of setting the surface that you're driving on. This just is because if you are on a low friction surface like ice, you will have more sideways slip. You will have more slip because it is a low friction surface. But in this case, we'll just be using a normal one. And then this next option, vertical non-slip, is the same thing but in the vertical axis. So this one you want to measure to the center of the steered axle. So in this case, it is ahead by 2 meters, and again it's in the center. So this adds constraint to the vertical axis. So when you do have the GPS dropouts, this just tells the RT that the vehicle you're in cannot just move upwards without any forward velocity, because cars cannot move like that. So again, it adds that constraint, and it just reduces the amount of drift you'll get. So those are all the measurements that you needed to take from your vehicle setup. This next page is just on the differential correction setup we have. If we're using RT base S, then these default settings should be correct. But it's worth checking just that the base station datum you set up is correct and matching here, as well as just the serial port settings. So if you'll change the baud rate on the radio, you'll need to change the baud rate on the RT so we can receive those signals, as well as the correction format on the base needs to match the correction format in the RT config. If you are using ntrip, you can also enable that here. It's just through this tick box, and that will send the GGA message through the serial. They'll just configure that so you can use your ntrip modem. Also, on our RT3000 v3 products, we now have an internal ntrip client, which again is just enabled through a tick box, and you can just input the ntrip host settings in here, just with the IP address and the mount point, and if you have a username, that can just be configured in here, which kind of simplifies the process a bit. We also have the option of using SBAS, so satellite augmentation system, which is just another form of correction. This is a free system, so it doesn't have volts, it's not centimeter level, it's more around meter position accuracy, but it will improve your position accuracy over SBS. So you can just select which region you're in, or you can select automatic if you are unsure. And this is similar if you have a TerraStar subscription, you can select the beam setting that you need in this setting here. So for this last page of hardware setup, if you are using a large, have an integration just with the Velodyne 16 buck, this just means it kind of simplifies the setup for that, so you can just log data over telemetry, as well as just set the enemy message synchronization a bit more simply. Moving on to the interfaces. Again, this is just the standard NCOM over Ethernet setup. You can lower the data rate if you'd like, as well as just setting triggers if you're using an APD robot. And this is where you just configure the driving robot IP, just with this tick box here. And this tick box comes on a safety feature in the advanced tools, which is output smoothing, which just means if there is a jump in position, that just moves out over a few seconds, just so there isn't a big jump and that can cause issues with the robot. The next page is, again, if you're using RT3, we now have Wi-Fi as an available interface, so you can either set up as an access point if you want to view the unit's data over Wi-Fi. If you just want to, you can just view that over. You can just connect to the Wi-Fi with your laptop, or you can connect the RT to an existing network. So, if you're using Trip, you've got your ntrip connections kind of sorted in a nice, neat way. The next is just CAN outputs. This is fairly standard. You can output all the messages that we offer. We do have CAN 2.0 or CAN FD, depending which standard you're using. And then to export the DVC file, it's just this button down here. And there's also the we offer a warning if you are going over the maximum suggested messages. If you do enable too many messages that we think will overload the CAN bus, you will just get a warning there. It's the same with if you're using the CAN acquisition. So we do have the ability to acquire CAN. You just import the DVC file that you're wanting to acquire, and then you can just select the measurements. The next page is setting up serial. So we have the standard serial outputs you expect, but the main one is NMEA, and you can just select all the measurements that you want, and you can change the output. You can pick in the output on triggers, and then you can also just select the baud rate, and you have the option to output approximate values before initialization if you require, which is just the tick box. With this, you'd also get a warning if you do go over the maximum characters, just so you can't set anything up. You can't configure anything that won't actually work. The next page is just analog setup. So we do have a additional piece of hardware called an RT Anna, which will allow, which just converts the RT signals into analog signals, and you can just set this up here. The next page is the PPS. So you can change to the active edge on the PPS. You do require either falling or rising. And then you can also output pulses per meter, as well as trigger input or output. This page is just for the environment that you're using. So if you want to use static initialization, if you do have dual antenna, it's just this tick box, or you can use dynamic initialization and set the speed. This speed is default to 5 meters per second, which works well if you're just using a standard vehicle. But if you are wanting to change this, I would advise not setting it too low, just because you do want to be able to drive around below this speed, just to be able to set up the car, the vehicle, so you can initialize in a nice straight line, because you do need around 50 meters, sometimes a bit less, of just straight driving for the vehicle to reach the initialization speed and initialize in a straight line, so you can get the initial heading value just from the GPS signal. You also have the option again of the GNSS environment. So depending what circumstances where you're driving, you can set these as required. Same with the vibration levels. You can also change the heading lock. So this just reduces the drift when you're stationary. So when you stop, the heading will just be locked to the value it was when you stopped. And you can kind of change the amount of constraint you have on it. If you are using local coordinates and you're using and you already have the values you want to do, you can just input them here. But you can also set them in real time using nav display. So now moving on just to the advanced tools page. We have gone through just the GNSS algorithms options a bit before, but again, yes, you just have the choice of using GPS calculations or the OxTS GXIX tie coupling option, as well as just the option to use mixed mode, which is just calculate them both simultaneously, and we'll just output the higher accuracy position. There's also the options for you to change the datum and the altitude reference. So if you do know the specific undulation, you can input this here, or you can just use the default. Next is just the wheel speed input. So this is again quite simple to set up. If you are using a wheel speed, we just need to know the distance from the RT to the wheel speed, as well as the pulses per meter that are outputted. The next there is the option of setting up wheel acceleration filters, both angular and linear accelerations. The next one is just output smoothing, which I mentioned is just to be used with if you are using an ABD robot. This just smooths out any big jumps you get in position. Just so you don't have any big jolts if you are using that kind of system. Next is just the position updates. So this is specific measurements just so you can choose the difference. How much the system trusts the GNPA card versus the IMU. So you can change these values, but the firmware defaults that are given should be in most cases and are appropriate in most cases. Next option is displace output, so you can change the output position of the unit is defaulted to the measurement point marked on the RT, but you can change this, for example, to the front bumper of the car or center of gravity. You just need to know the position relative to the RT of this place. The next one is just the science. So you do have the option to access curvature for up to 8 additional points. And you just input the distance away from the RT that you want these measurement to be to, and it will output them. This next one is just you have the option to add advanced commands to the unit's configurator. These are generally needing a very specific case. Us at OxTS will send a command, and this is just where it will be inputted. And this last page is just the accuracies of all the values that you took in the beginning of the hardware setup. They're kind of put into one page, and just leaving them as the standard 10 centimeters, 5 degrees, as standard for all of them. But when you do get improved settings, these will become type tolerances, and I'll just improve the warm-up time you need, just because the configuration is known to a higher accuracy. And then this is just writing the configuration. So when you come to do this, when you connect to the unit, it'll just be in this drop down. You can commit it, or you can save the configuration using the floppy disk option. And now just these last two options down here. This is the information tab, and this just has the feature codes that are currently enabled on the unit. To a unit live, you'll also have the option to update feature codes if you've been sent new feature codes. And this last page is just the hardware information. Again, it's only available with your settings. You can change the NAS and the road configuration for NAVconfig. So now I'm just going to go back to the slide. And so once you have configured your unit, the next step is to initialize and to warm up. So to initialize, if you're using dynamic initialize, you just drive in a straight line, accelerating through the initialization speed, and then you'll see on, if you're using nav display, the unit will start outputting in real-time mode. And then from this moment, you have the first 15 minutes after initialization, the unit is in warm-up mode, so it's ready to be warmed up and will apply those changes to the configuration. So you can change the lever arm settings. The RT will learn where the antenna is relative to the RT to do these maneuvers. So things like figures of 8, doing circles with a decreasing radius, slaloms, and hard acceleration and braking. Will just all help the unit learn where the antennas are relative to the RT itself to a higher accuracy. And you do that the testing. So if you're doing a really high dynamic testing, if you do normal kind of testing, then that's the kind of speed you should be doing a warm up at. Once you have done a warm up, next step is to get improved settings. So this means that you save those time tolerances onto the unit's configuration, and means next time go to do a warm up, it'll be a short quick warm up, just sensors. So what this does is when you do install the RT, it's very hard to perfectly align to the 0.1 heading you have. So if you do have these advanced slip settings, just the axle, the RT can calculate the forward direction of the car relative to the RT view. That's the kind of more settings to, and then do
It appears we've had apologies for the slight audio issues we've been having here. So I think we're ready to go through to the questions now. So okay, I think Lily's having problems, so I'm going to endeavour to answer as many of these questions as I can. So first question, in the environment tab, can we combat minimise the wind effect in our data? Crosswinds, lateral G, roll and so forth. No, the environment tab isn't for that. The environment tab is more for setting units up your operation, so your GPS weighting and so forth. However, during your warm-up, the unit will learn if there's any sort of form of offset and try and account for that. It might be better if we talk to you outside of this meeting through the support tickets and try and help you get your best solution. Next question is, what kind of patterns in log data would indicate that you might need to remeasure positions or otherwise update your configuration? I'd say the things for that would be, what we will be looking for when we're post-processing is innovations, and you can look for these in real time as well. Innovation should be fairly consistent. If they're spiking all over the place, it would indicate a low level of confidence between where the IMU thinks it is and where the GPS receiver says it is. Hope that answers your question. Would you change your vibration levels if you knew you would be driving on a rough surface, cobblestones, etc.? Yes, you can. If you know you're going to be driving in a high vibration environment, or you can change your vibration settings in advance. However, if you realise afterwards you've got your settings incorrect, you can change these in post-process. And I would recommend, if you haven't already, attending Sam Solomon's webinar on post-processing using NAVconfig and NavSolve and NavGraph. I think this is when we started having audio issues. I hope you can all hear me now and this one's okay. Process during get improved settings. It was, what does the process look like for a quick warm-up? Is it just a built-in feature or just a shorter warm-up time? The overall process for using get improved settings is you would set your configuration in your unit, and with normal tolerances on your lever arms, and then you would go and do a warm-up for a period of 15 minutes, doing a period of a variety of different dynamic motion. At the end of that, we can do something called get improved settings, and that would commit your revised configuration, your improved configuration to your unit. Any subsequent runs after this would still require a warm-up, but it should be cut down. However, it's important to remember with get improved settings that you should only do this in RTK when you've got differential corrections. So I think we possibly might have Lily back with us. So if we do, she can answer this one. Otherwise, I'll answer it. It's regarding antenna lever arms, and it says antenna position accuracy is 100 millimeters. Does that mean we can put the antenna anywhere in 100 millimeter circle radius and the result won't vary?
So firstly, Caroline, can you hear me?
Yes, I can. Welcome back, Lily.
Okay, great. So you should still measure the antenna placement as accurately as you can, you know, just using a tape measure. And then just setting the tolerances means you do just have a bit more space around that. This also this 10 centimeter also includes the orientation offset. So if you do have your RT angled wrong, then the position that you've measured from that angle offset is kind of taken into consideration with this 10 centimeters. So you don't want to just put it anywhere within that 10 centimeters because there may be other offsets that are adding to that error. But it does just mean that if you're using, like if you have base station corrections, the RT just has some space and it can just find the actual position and it will lower the tolerances. But if you are quite off, it will just take longer on the warm-up to find the correct actual value for the lever arm. So the better you measure the lever arms in the first place, the shorter the warm-up will be to get within tolerance. But if it is somewhere that is very difficult to measure to, then if you are, you know, within the 10 centimeters, you should be fine, but it's still best to measure it well the first time.
Thank you, Lily. Any other questions from anybody? I think otherwise we're pretty much through them. So yeah, please accept my apologies for the audio issues. I hope you managed to get those out, or we've managed to answer any gaps you had during the questions at the end. There are some other webinars running throughout the rest of April, and we've just put some more out for May. So yeah, please sign up for those. There's ones on post-processing and some, I guess, moving on from this, more advanced settings for challenging GNSS environments. And if you're installing one of our units on a drone as well, there's 2 separate webinars there. So, we will be distributing a copy of this webinar, so you'll have a recording of the presentation and the questions that following this anyway. Thank you all for joining. I hope to see you in another webinar soon.
Yes, thank you, Caroline.